Welcome back to this channel for solutions to practice problems for actuarial exams. You have some information here about the websites that tell you about who I am and about educational products I offer, and the great actuarial program at Illinois State University, where you can find information about it at smarturl.it/actuary. As you can see, I use this redirect service, smarturl.it. It redirects to the website that I associate with the word actuary. And if you would like to make a tax-deductible donation to the actuarial program at Illinois State University, go to smarturl.it/help ISU actuary. We have an $80 million interest rate swap that has a remaining life of 15 months. Under the terms of the swap, 6 months LIBOR is exchanged for 10% per annum, compounded semi-annually. LIBOR rates with continuous compounding have been the same for the past 3 months and are shown by maturity below. 3 months is 8%, 6 months is 8.25, 9 months 8.50, 12 months 8.75, and 15 months 9%. Calculate the current value of the swap to the party paying floating rates, so that's the party short the swap. Assume that the floating payment at the applicable rate is made at the end of the period for which the floating rate is calculated, so the settlement in the arrears, and that both sides' payments are made every 6 months. Here are the possible answers, so you can see that it's possible that the value of the swap to this party could be negative or positive, and we need to figure out which one it is. Well, 5 possible choices. So there are 15 months remaining in the swap, and payments are made every 6 months. So there will be made 15 months from now, when the swap ends, 9 months from now, 6 months before that, and 3 months from now, 6 months before that again. The payments and their value will be as follows. In 3 months, the pay fixed side will pay 5% of 80 million, so 4 million, while pay floating side will pay 6-month LIBOR for the period from 3 months ago to 6 months in the future. And since we know that rate to have been 8.25 continuously compounded, identical to the current 6-month LIBOR, we know that the floating side payment will be that rate over half a year as a continuously compounded rate. So e to the 0.0825 times 0.5 minus 1 times 80 million, which ends up being $3,369 $8.09. And the actual payment will be the net of the two. So 4 million minus 3 million something, which is 630,991.91 paid by the pay fixed side. In 9 months, the pay fixed side will pay again 5% of 80 million, so 4 million, while the floating side payment will be determined from the 6 months LIBOR for the period from 3 months from now till 9 months from now, which right now is represented by the forward rate between 3 months from now and 9 months from now, calculated as the effective semi-annual rate from 9 months and 3 months and 9 months current spot LIBOR rates. And if these were annual rates, you should remember that if you go from time 0 to time 1, for example, and then time 1 to time 2, the time 0 to time 1 spot rate is the same as the forward rate for that period. So 1 plus the spot rate for the first period times 1 plus the forward rate from time 1 to time 2 is equal to 1 plus the spot rate for 2 years squared. And in this case, in a sense, you can think about the 3/4 of a year rate to be that spot rate over 2 periods. And then we divide that by the spot rate of a shorter period, and what we get is the forward rate from time 0.25 to 0.75 in years. But we need it as an effective rate. Hence the floating, and that's how we get it. The floating side payment will be approximately 4.472114% of 80 million, or 3,577,691.36, and the actual cash flow will be the net payment of the two, and it will be made by the pay fixed side. In 15 months, the pay fixed side will pay 5% of 80 million, so 4 million, while the floating side payment will be determined from the 6-month LIBOR for the period from 9 months from now till 15 months from now, which right now is represented by the forward rate between 9 months from now and 15 months from now, calculated as the effective semi-annual rate from 3 months and 9-month current spot LIBOR rates, just like before, comes out to be 4.995783%. So the payment will be almost 4 million, but not yet there. And again, the fixed side will have to make that payment. And in 15 months, there's also 80 million principal on both sides, but since this is identical, an identical amount, no principal exchange is necessary, and even if it were done, it would be irrelevant if I give you 80 million and you give me 80 million. This is good news because we both have 80 million, but nothing really happened. And finally, the value of the pay floating side is the present value of the 3 net payments that the floating side will receive, and we can calculate that their total present value using the spot LIBOR rates given, and comes out to be a little bit over $1 million. An alternative approach would be to point out that in 3 months the floating payments will refer to $80 million principal and then market value of LIBOR, so the principal amount of 80 million will be worth 80 million in terms of market value. Therefore, we can calculate the value of the payments made by pay floating side, including principal, as the value of the first interest payment in 3 months, plus the value of principal paid at that time, 3 months from now. Now, the next floating payment is the interest due on 80 million at 6-month LIBOR from 3 months ago, identical to the current LIBOR. Therefore, that amount of interest paid in 3 months is $3,369.09. Together with the 80 million principal, the current value of the floating side payments is 80 million plus that, discounted at an appropriate rate, 81,718,191.10. And the remaining fixed side payments are 5% of 80 million, so 4 million in 3 months, 9 months, and 15 months, plus the repayment of principal of 80 million in 15 months. And so they have the present value of 82,735,930. And the value of the swap is the difference of the two. And since the pay fixed side pays more, then it's the value to the pay floating side. So the point we're making here is that pay floating side is like a money market account. So its principal does not disappear. So we can just assume that its value after the first payment of interest will be 80 million because it pays the going market rate all the time. And that's why we can simplify the problem somewhat by doing this. In any case, we get the same answer. It's answer E. Please remember this is copyrighted material, and also all problems from Society of Actuaries and Casualty Actuarial Society exams belong to them and are reproduced with permission. Good luck with your studies and on the exam.